Hi guys, my name is Diego Saballos. I'm the manufacturing lead and part of the suspension development team for Longhorn Racing Electric. Today I made a part called a strain gauge plug. Basically what it does, it's going to be put on our push rod, and our push rod connects to our suspension. So any wheel travel, up and down travel that the wheel experiences, the suspension takes care of that, and that force is transferred through the push rod. So the way I made this part is basically turning on the lathe. It's called like kind of machining term, turning on a lathe. So basically I get this stock aluminum stock was about 3/4 in diameter. You have like a major diameter and minimal diameter. So the major diameter of this part was about 5/8 of an inch. So I turned that down to that diameter, and then I kind of progressed from going to our major diameter to our minimal diameter. And our minimal diameter was about, I believe, 0.4 inches, and that is a pretty tight tolerance. That middle section, that 0.4, that smallest diameter, it's kind of like in between both of those two diameters that I mentioned before. So what I did is I turned down the 1/2 inch diameter to where like the minimal diameter met the major diameter, and then turn that down so I know where I would end. And then I kind of made an indentation with a little triangle lathe tool to show where I needed that thickness of that diameter that I'm going to turn. And I turned it down to diameter. I used some like little tricks using different tools. I don't know if I was the best. This is kind of like the first time I did it. I kind of just free-handed it, I guess, freestyled it. To turn that diameter down, I reached within about 5/1000ths of an inch, and that hit the tolerance that was necessary for the drawing. So I turned it down, and then I drilled holes, one to conserve weight, and another reason was to make sure the strain gauge reads a certain amount of strain. So if I were to keep the section where the strain gauge was solid, there probably won't be enough strain because there's so much material kind of resisting that strain that it won't read anything. If anything, it'll be very small. So what you want is you want a thin wall, basically the difference between your major and minimal diameter gets you your walls, like the thickness of the cylinder, for example. So you want a certain wall thickness in order for the strain gauge to read that strain or load that it's experiencing. We kind of calculated this doing some basic solids hand calcs and FEA to validate it, to make sure it would read a certain amount of strain and experience a certain amount of deformation. Deformation in a material is, for example, the amount of material deforms basically from its usual state, for example. And then so I drilled those holes, several drill bits, and then I tapped one end of it to a 1/4-28, which is where a rod end is going to be attached, and that rod end connects to the upright, and the upright is basically the whole part of the whole wheel assembly. So the plug I made, it's a little more complex than our usual plug. Usually it's just like a plug with an indentation, and then we put in our carbon fiber tube. But this year we wanted to integrate direct acting suspension, which is basically just, it's like a suspension coilover and a push rod combined all in one assembly. It saves complexity, and we also wanted to integrate strain gauges into that part. So basically what a strain gauge does, it's like tiny. It basically is able to measure the electrical resistance through the metal. In this case it's aluminum, and through that reading you're able to kind of calibrate it and be able to get the amount of strain the part goes under, or the load that it experiences. And basically the reason why we want to integrate this into our suspension is to validate our vehicle modeling. So we basically want to make sure the real world lines up with their programming. So that's just some more validation on our end. And then that will lead to better geometries for the suspension or the frame, for example.